Welcome everyone. Sorry for the Spanglish during these first minutes. I'm gonna be introducing everyone, and then I'm gonna give you the word, Dr. Yeang, please.
Okay.
Listo. Buenos días con todos. Muchísimas gracias por su espera. Muchísimas gracias por su interés. Bienvenidos. Es un honor tenerlos el día de hoy en esta masterclass virtual, parte de nuestras Bioclimatic Talks organizadas por Bio Academy, Universidad Católica Santiago de Guayaquil, CEP, Constructores Positivos, como antesala del Diplomado de Diseño Bioclimático. Hoy tenemos el privilegio de contar con un ponente excepcional, quien nos hablará sobre bioclimática y diseño ecológico. Voy a darle la palabra en este momento a Mauro Cepeda, quien nos dará unas palabras de bienvenida.
Hola con todos, mucho gusto saludarles, gracias por su interés y por conectarse a esta nueva sesión de las sesiones de bioclimática. Para nosotros es un honor haberlo contactado a Dr. Yeang, que nos pueda estar aquí acompañando en esta sesión y que sea una introducción y un preámbulo a este gran diplomado del diseño bioclimático. Sin más palabras, adelante Marisa, muchas gracias.
Muchísimas gracias, Mauro. Quiero introducirles y quiero presentarles también a Félix Chunga de la Torre, quien es director y docente a tiempo completo de la Universidad Católica Santiago de Guayaquil de la carrera de arquitectura.
Buenos días con todos, bienvenidos a esta masterclass. Les doy la bienvenida a nombre de la Universidad Católica de Santiago de Guayaquil y comentarles que hemos emprendido este desafío, este reto de hacer un programa de capacitación profesional en temas de diseño bioclimático, que es tan importante en este momento para la formación de profesionales, para la actualización de profesionales, y lo hemos hecho de la mano de unos representantes muy importantes en la industria, Bio Academy, que nos ha apoyado en este y varios emprendimientos que hemos tenido ya en algunos años ya. Les queremos a todos dar la bienvenida a esta semilla, a este inicio de un largo camino que hemos querido emprender y que sabemos que va a dar frutos importantes. También queremos dar la bienvenida. Professor Yeang, welcome again to our university. It's been a while. Last time we saw each other was, I think, in 2012. So we are very excited to have you here again. Welcome to our university. And I hope you have a great conference, and I appreciate your guidance here in this road to sustainability. Bueno, bienvenidos a todos. Prosigamos con la conferencia, con el masterclass, y es un gusto tener a todos aquí.
Muchísimas gracias, Félix, por tus palabras. Dr. Yeang, it's going to be just a little few minutes for me talking in Spanish. I'm just going to introduce yourself to everyone. Tell everyone a little bit about your work, your project. So in just a few minutes, I will give you the space to start. A ver, bueno, les comento que Yeang es arquitecto, ecologista, planificador, es nacido en Malasia, es mejor conocido por su arquitectura ecológica y sus planes maestros que tienen una estética verde distintiva. Es pionero en arquitectura basada en la ecología desde 1971, trabajando en la teoría y práctica del diseño sostenible. El periódico The Guardian lo nombró como una de las 50 personas que podrían salvar el planeta. La sede de Yeang está en Kuala Lumpur, en Malasia, pero también tiene oficinas en Londres y en China. Se licenció en arquitectura en la Escuela de Arquitectura AA, Architectural Association en Londres, donde realizó ilustraciones y trabajos gráficos independientes para algunas revistas. Su disertación en la Universidad de Cambridge, un marco teórico para incorporar consideraciones ecológicas en el diseño y planificación del entorno construido, le significó un doctorado publicado como Designing with Nature y cómo proyectar con la naturaleza. Yeang ha completado más de 12 edificios ecológicos bioclimáticos, varios miles de viviendas, más de 2 millones de pies cuadrados de espacios de diseño interiores numerosos planes maestros ecológicos y ciudades de diseño ecológico. El Dr. Yeang ha dado numerosas conferencias en congresos y escuelas de arquitectura en más de 30 países alrededor del mundo. El trabajo técnico y de investigación del Dr. Yeang se centra en la arquitectura ecológica y la planificación, estableciendo la base formal para el diseño, centrándose en la biointegración de lo creado por el hombre con la naturaleza, creando sistemas híbridos como ecosistemas construidos. Su trabajo adopta el diseño bioclimático, es decir, un diseño pasivo sensible al clima, como una parte del diseño ecológico. El enfoque también genera características regionales críticas, donde las respuestas climáticas proporcionan vínculos con la localidad. Sin más preámbulos, les dejo con el Dr. Yeang. Dr. Yeang, it's such an honor for me to introduce you, welcome you, and thanking you for sharing with us today. The stage is yours.
Thank you for introduction. Yep.
Yep.
Let's get started.
You're okay to go.
Okay. Good. Right. Hello, everyone. Many thanks for the opportunity to speak to you. I'm going to talk about the work that I've been doing for some time now. It started with bioclimatic architecture, and then it has moved on to ecological architecture. So today I'm going to talk about the nature-based architecture that I've been working on, driven by the science of ecology. The designing starts with, can you just move this down? I can't see, read the top. This thing is blocking everything. Why can't you move this down and move it to the side, or get rid of it,
This one, I think this one.
Huh?
Cannot move this one. More.
Solo unos minutitos, por favor, hasta que puedan compartir bien la pantalla.
Let's use this. Okay, all right. Okay, sorry about this. I'm
No, you need this one. Okay.
okay. So let me start again. Sorry about that. The science starts with looking at the planet's ecology as the baseline and context determining its health. Nature consists of the biosphere, which is the thin film that surrounds the planet. Within this film, there are units in nature which are ecosystems. And the ecosystems consist of biotic and abiotic constituents. Biotic are the biological constituents, abiotic are the physical constituents, acting together to form a whole system. But within the ecosystem, there are very complex processes that are not all visible to human eye. So sometimes when you look out at nature, you see nothing. All you see is just trees or grass and bushes. You think nothing's happening there. But actually, there are very complex processes where the plant communities interact with the soils, with the climate, and with the hydraulic processes. Now, within nature, there is a human society. And we are part of nature. We are one of the species in nature. But we're the most powerful. We can change landscapes. We can change waterways. We can remove species. We can cut down large tracts of trees. And we can change the climate. And then we make things. We make the built environment, which is not just buildings, but artifacts, everything that are human-made. And as a species, we make more things than any other species in nature. And we clutter the whole planet with things that we use that we don't want, we throw away. But there is no way. The planet is a closed system. So everything that we use, that we make, that we throw away has to go somewhere. And so much of the greenhouse gases, the air and aquatic contaminants are caused by us as human beings, by the electricity we produce, by industrial systems, by commercial and residential construction, by agriculture, production, by transportation, and our other human activities. And it's because of this that the planet is in a desperate state. Now, when I first started working in ecological design, maybe 10, 20 years ago, the purpose of ecological design was to have minimal impact on the environment. But what we've done to the planet over the last 10, 20 years has been so extensive that now it is a race and rescue mission. We have to rescue the planet. So there's not much time left. And what we've done is that we have caused major climate conditions and changes like forest fires and flooding and so forth. And so, but besides this, we need energy systems because we are addicted to energy. We cannot exist without energy. And then there is the water system because we need to live with water. And so ecological design is these 5 factors integrated to form a whole to create what I call the human-made ecosystem. These are some of the factors that we need to consider in nature, in human society, with our built systems, with our energy systems and hydrology systems. I'm going to proceed with this very quickly, but if you check on my website, you find this diagram in it. So now what do we do? So my contention is that we have to imitate ecosystems. So to imitate ecosystems, we have to understand what are the attributes of ecosystems. So that's the first stage. These are some of the attributes of ecosystems. Ecosystems is a biological structure, has a high level of biodiversity in most parts of the world. Ecosystems are connected. Ecosystems provide ecosystem services, which are things that nature does for us without human intervention. The systems are biointegrated. they're responsive to the climate. The materials in nature naturally cycle by themselves. Nature produces pure water. Nature interacts with each other in a symbiotic way. Nature reacts to disturbances. Nature produces its own food. And nature grows and changes over time, which ecologists call succession. Then nature produces what you call ecosystem services. These are things that nature does for us without human intervention. It produces oxygen. It does photosynthesis. It absorbs some of the pollutants in the air. So these are some of the services that nature gives to us without our human intervention. But with the devastation of the planet, the ability of nature to provide these services is decreasing. And so we should be careful what we do. I can't see my own picture either.
Because you share,
Sorry?
because you talk, so they can see you.
No, I should be able to see myself.
If I put this one, so
Yeah.
this one.
Okay. So now the ecological design means we have to mimic nature, replicate, emulate, and augment nature to create what I call human-made ecosystems. Firstly, what are you doing? Actually, why is that cannot move change, right? These are too big. Is it possible to reduce these?
No, cannot.
Huh?
Cannot. Only this one. So this one small.
You move it down, Yeah, okay. Down. Fastly. You should have done this just now, while waiting for them. And so the purpose of ecological design is to create what are called design systems as human-made ecosystems. It's not possible to put them here.
No.
So these are the services that nature provides for us without human intervention. Now, if we were to imitate these, then we find that it is almost impossible for us to replicate nature in entirety. Nature fixes solar energy. Of course, we can do this using photovoltaics, but not in the same extent and as magnitude as in nature. For instance, nature absorbs a pollution, detoxification of human industrial waste. Yes, we can develop technological systems to do this, but again, not in the same capacity as nature. And so it is clear that current technology is unable to operate at the same scale provided by nature. So that is the biggest problem in ecological design. We want to create human-made ecosystems, but the current technology is not able to do it in entirety. And so one solution is that if we cannot replicate, it's impossible, it's difficult to emulate, and difficult to mimic, then the solution is to cooperate with nature, which are called augmentation. We augment by integrating of habitats within the built systems. And so this is what I try to do at the outset of my work. How to create habitats within the built form. If you look into existing cities, the biological structure, you find that existing built environment is mostly abiotic. It is physical, has no nature in it. So where is the biotic constituents in our built environment? Very little. And so our work then starts to look at how to create habitats within the built form. Some of this could be green roofs, some of them could be vertical greening, some of them could be green sky courts, greater green areas, and so forth. So I started to look at patterns in which we can put habitats into buildings. You can put it all in one location. In terms like in New York, you put it in Central Park, or in a building, you can put in one location. You can have a spotty relationship, like in Georgian London, where you have a series of green squares. You can have a stepping stone relationship where the habitats are close to each other, but not quite connected. That some species can move from one patch to another patch. Or you can have a tree with spines, as a spine with fingers sticking out. But this is the ideal configuration. The corridor with fingers, habitats, is connected. By being connected, there's a larger pool of connected resources to be shared among the species. It engenders a much more stable ecosystem, and then engenders a much more biodiverse system. And of course, the idea would be to cover the built environment in entirety with greenery. So I call this the infused system. So these two are the preferred. They're preferred because the habitats are connected within the built environment, linked to the hinterland, repairs fragmented ecosystems, and so forth. What is clear is that even if you have large patches of greenery, it is too far away from most of the built areas. So we need to link the green areas are connected with the built environment or the built systems as closely as possible. And so this is the ideal solution, which is to have an ecological corridor with ecological fingers that eat into the built environment. I call this close weaving of green fingers in proximity to urban realms. And so for the provision of ecosystem services, one solution is to weave the greenery with the urban areas. So this is a scheme that we designed in the Reunion Island, which is east of Madagascar. The urban areas are about 30 meters wide. The green fingers are about 20 meters. And that's the first thing we did was to collect all the species by the waterfront and bring them into between the built up, into the urban areas. And then we weave the two together so that the urban realm and the green areas are sort of cheek by jowl next to each other. And so this is the perspective how it looks like. Yellow are the green fingers, and that this is the urban fingers that move, go down towards the between the green areas, and that the black arrows show how the green areas, by being close to the urban areas, provide ecosystem services, but indirectly. And so now what happens is that we have roads cutting across the entire site. And so to enable connectivity, we have what we call an eco undercroft, so that the greenery goes underneath the road. On the right-hand side shows the other options, which is have the greenery go over the road, which I call eco bridge, and when it goes underneath the road, I call it the eco undercroft. The edges of the urban realm should not be pristine, should not be sharp and the separate between the urban areas and the green areas. It should be serrated so that species can hide, species can breed, species can protect themselves from other species. And so this is how nature is. Nature is not as crisp and clear cut as it is with a lot of human-made systems. And so we should try and connect it not just horizontally, but bring it vertically up buildings. So in this way, we create what we call a vertical urbanism of greenery that is connected from the ground to the top. So with this scheme, what we did was that we had a ramp that starts from the ground, weaves its way up to the top of the building, where with every floor, the ramp climbs up. The ramp climbs up one floor for every facade. And so in this way, we can enhance the biological structure, we can increase the biodiversity, we can increase connectivity, and we can provide ecosystem services at the same time. So this is what I call, on the right-hand side, you can see the link pattern of vertical integration of habitats with the built form. So this is the scheme that we designed in Singapore. The vegetation climbs up on the facade. At the corners, we open it up to create sky courts and sky plazas. And that you can see how the vegetation climbs up from the ground. With every facade, we climb up, with the ramp climb up one floor to the mid-level garden and to the roof. This is the building seen from a distance. That's the surrounding buildings. On the far left is the building by the famous Japanese architect Kisho Kurokawa, and the other buildings are by other architects. But here's a detail of the vegetation. It is on the outside of the building, so that to service it, we don't have to go through the internal spaces, and people can service the vegetation from the outside, and you can see the sun shading on top and the glazing on the back. So this is how it looks like. It's the service walkway, and then where it meets a corner, we open it out to create a plaza so that people could meet the ramp, or they could meet the people climbing up the ramp. They can go out, have a cup of coffee there, or have a cigarette or whatever, or they can just discuss, have meetings there. So these are located, as you can see on the left-hand slide, at the edges of the building. Here's the vegetation on some parts of the building. You can see the walkway. But the building really consists of two components which are linked by bridges. And here, this is the vegetation again. Now, nature sequesters aerial contaminants. And so this is a function of these vegetation on the outside that absorbs the contaminants. This is a set of plans for the building. And what you can see there here is that at the mid-level, there is the garden. There is a series of gardens that step up. But at the middle, I have an operable atrium with the atrium below, and the vegetation climbs up to the roof garden. So this is the roof garden on top of the building. This is the roof garden at the mid-level. And then at the corners are the sky terraces. The ratio of the green areas to the site area is 12.2. And so we have 12 times the site area of vegetation within the building. These are the sky courts at the edges of the building. And as I mentioned earlier on, these are spaces where people can hang out if they are, and enjoy the outside environment without, if they don't want to stay inside the air-conditioned, not a mechanically ventilated environment. That's the view of the building from the side. You can see the mid-level sky court and the roof garden and top. We brought the vegetation all the way down to the ground floor and into the basement. We call this the eco cell. But between the two buildings, I have an atrium, and above the atrium is a glass roof. And this is operable. On a normal day, it opens, but if it rains, it automatically shuts. So this is the naturally ventilated part of the building, and this lowers the energy consumption because the space is not air conditioned. I just have cold air being blown into the space. And the two parts of the building, the left and the right, A and B, are linked by a bridge so that you can go from one part of the building to the other part of the building from the lift core or from the passageway between the two buildings. So this is the aerial roof, and that these are the bridges between the two parts of the building. These are the sky courts, and then this is the what we call the eco cell that we bring the vegetation. You can see in the bottom right all the way down to the basement. The eco cell idea originated maybe about 20 years earlier. This was our design for the Kowloon waterfront. It was a competition which we didn't win, but it was an idea where we explored the idea of the eco cell. So on the red square is the eco cell, and the eco cell does a number of things. It brings vertical integration of vegetation to the basement, provides opportunities for collecting the rain, for harvesting the rainfall, provides natural ventilation, brings daylight. And the bottom of the eco cell, we can have a living machine for treating the waste. And on the top drawing are where the eco cells are located. So this is the glass roof that I mentioned earlier on, and that is just looking up towards the glass roof. But on our left-hand side is another experiment where we had what we call a diagonal light shaft. The light shaft is something that we use to bring. This is a simulation of the daylight on the floor. It shows the defective aspect of my design, where the middle of the floors tend to be a little bit dark. But the light shaft is something that we use to bring daylight into the inner parts of the building. And this is diagonally cut. You can see that on the drawing on the right-hand side into the floor, and you can actually look down and see the street. And this is from the street looking up, you can see the skylight. And this is the street looking up the light shaft. So here's another scheme where there's a competition scheme which we did not win. We got second place, which is the Edith Tower. And it is it adopts the pattern of the spiraling vegetation that goes all the way up to the top of the building. So this was the embryo, this beginning idea of the other scheme. This was done about 10 years earlier to the Solaris building, the one with the ramp on the outside. And here we had continuous vegetation, but I didn't have the walkway. The walkway was introduced in the Solaris building. But the idea was that we have sky courts, green areas in between, and that where the ramp reaches the same level as the adjoining roofs, we would bridge over, and then we would green the roof. So it becomes the building then becomes a catalyst, a device for greening the city. Was an idea, but it was not 100% adopted. Here, this is a data center where we brought the vegetation from the ground and ziggurats across the building on all facades, going all the way from the bottom up to the top of the building. And on top of the building, I have photovoltaics. You can see the slightly tilted roof where the photovoltaics to bring solar energy to the public areas and the lift lobbies. And this is the vegetation going all the way up to the top of the building, and this vegetation in the facade. Here's another scheme where the vegetation then climbs within the frame. So it goes up, at the back between the red frame and the building on the inside. It's a cultural building, so you can see the Chinese letters on the left-hand side and how it's reflected in the frame on the outside. This was a scheme that we did about 25 years earlier, which is the building that we did for IBM. But as you can see on the right-hand side, it is a stepping stone concept. The vegetation is not connected, but it is close enough so that certain species can climb from one part of the vegetation to the other part. This is another one where we had series of sky courts. We want to connect it, but we didn't quite achieve it. And then, these are the sky courts within the building. The sky courts are about 3 stories high. And then another building we did around that time where we had sky courts at the edges. You can see the plan. The sky courts are at the corners. You can see the greenery. At that time, we were also exploring the idea of the bioclimatic skyscraper. The bioclimatic skyscraper means that the lift core is on the outside of the building. You get natural ventilation and you can see out. The staircases are naturally ventilated and the toilets are naturally ventilated. But on the left-hand side, you can see different configurations of the core. But the red square shows that the core on the east and the west side creates a building which is low energy, which uses the lowest air conditioning. And so these were some of the studies we did maybe about 20, 30 years back. And then for this building, which is just we completed about 5 years ago, the sky courts are those little black slits. But here we experimented with a different way of sun shading. Instead of using horizontal louvers, we use fritted glass. But the building lies almost by the waterfront, and that it is actually 2 almost symmetrical chevron-shaped buildings, which lies along the axis from the square along the boulevard right down to the waterfront. And the waterfront is the monument, which was also designed by us about 8 years earlier. One of the things we look at when we first start designing is to look at the biodiversity of the location. These buildings are very, are locations which are very highly biodiverse, and the thick white line shows the equator, and you can see the high level of biodiversity on these locations. But as you go further up the equator, the planet gets increasingly, the locality gets increasingly lower in biodiversity. So for instance, London is 52 degrees, and you can see the biodiversity is very low compared to the biodiversity at the equator. We do species on the fauna that we want to bring back to the site. And so, we look into not just animals, we're looking into birds that we want to bring back to the site. And then, as I said, these are the habitats we create within the building, on the ground, on the facade, in the sky courts, and so forth. And that once we created the habitats, we look into the fauna that we want to bring back to the site. Those are the fauna that we saw earlier on. Having identified the fauna, we look into the flora that will track the fauna, and then we look at the interaction between the habitats with the fauna and the flora, and this provides opportunities for us, clues on how we can design the landscaping and the habitats. And so we call this the biodiversity matrix approach for designing habitats and landscaping within the built form. We sort of semi-invented this together with our ecologists. So this is the central sky court. This is a central promenade with the green areas and the trees which are being planted. And we started to experiment that instead of having horizontal louvers, which is in the conventional sun shading, we started to use fritted glass panels. These are panels which are placed they're not butt jointed. There's an air gap in between. But the fritted is about 50% proof of white, so that we can let some of the light through, but keep 50% out, and that that they are placed. You can see the cross section. You can see the fritted glass. So it's a double skin. We have an inner skin and then the outer skin fritted glass, and then there's a walkway in between to service the glass from both the inside and the outside. And that the aesthetic is, we faceted because to make it look upmarket like a gem. And so it's a series of faceted facades on the facade on the building. And then we chose a cultural pattern, which is representative of the local culture, the Malay culture. And on the middle there in that drawing is the headgear that the royalty wears, and we adopted the pattern for the glass, so that the fritted pattern is a cultural pattern that has a memory of the culture of the locality. This is a central square where you can see the two chevron-shaped buildings. They are almost symmetrical. They're not exactly similar, but we had to keep this axis. So by keeping the axis down to the monument from the square, the two buildings then have that shape. And then the buildings are not so thick that I have dark areas now. They're about 15 meters from glass to glass. And that we call this the double skin fritted facade. On the west side, we angle it so that this protects it from the sun. And so you can see the fritted glass panel. This is the walkway in between. And you can see the walkway. And then from the inside looking out, this is what it looks like. You can see out. It doesn't obstruct the view, but it enables you to see the outside. The typical office building uses about 210.52 kilowatt hours per square meter per annum. But by using this fritted glass sun shading, the energy consumption is reduced to 136.18 kilowatt hours per square meter per annum. So this is one of the advantages of green design, where we reduce the energy consumption of the building. So this is the west facade. You can see the double skin fritted glass on the west side. But the building has this axis that cuts through in between the two blocks, which leads onto the monument, which is by the waterfront. And you can see the monument on the left-hand side, and you can see the two buildings and the square. That's the bridge, and it lies along this boulevard on the right-hand side that leads to the Prime Minister's residence, which is on the right-hand side. And then by the waterfront is the monument, which is also designed by us about 8 years earlier. And that the monument then is surrounded by the Ministry of Finance buildings, which were designed by a friend of mine. So these are the different parts of the building, the green areas, and this is the access to the monument. And the bottom monument, as you can see on the top right-hand side, is a ramp. The ramp follows the pattern of the hibiscus flower, which is the national flower for Malaysia. And so, we constantly have a cultural reference for our design. And these are the realms between the two blocks. And this is the vegetation, the eco-style that brings vegetation all the way down to the basement that you can see on the right-hand side. And next to it is the walkway that brings it all the way down. And as I mentioned, these are the eco-style. These were the earlier project from which we developed the eco-style idea. This is the blasted tower, where, as I mentioned earlier on, we have the sky courts and the vegetation. And this explains the location of the lift core and escape stair, as they're on the east and west side, that reduces the energy consumption of the building. Now, how do we do this in the vertical building? And so what we try to do, as I mentioned earlier on, is to connect the vegetation, not just horizontally, but vertically up the building. And this is a building now under construction where we have, I call this the spine with the fingers sticking out. And you can see the building on the right-hand side with this green wall climbing up, and the sky courts. And the sky courts are at the corner. There are 5 of them, 1, 2, 3, 4, 6 of them going all the way up to the top of the building. The sky courts this is an apartment building, so these are sort of spaces where the people who live in the building of that particular floor can go out and enjoy the outside environment. They can have parties there. They can have meals there. They can actually play games there. So and they also enjoy the surrounding view. So these are the sky courts on the edges of the building. But before we designed the building, we started to look at the ecology at the macro level, which are the green areas surrounding the site. We look at the ecology of the areas which are in a close proximity to the site. We started to look into what we want to bring back into the green building. For the lower floors, we wanted to use butterflies. For the middle floors would be the songbirds. And then the upper floors would be the migratory birds. And so this is our scheme for the green areas for this building: dragonfly zone, butterfly zone, songbird zone, and the migratory bird zone. And that these are the flora that will track the fauna. And so this, if you like, is the biodiversity approach towards increasing the biodiversity of this building. And these are the different species we adopted for the project. The top of the building is a swimming pool, and there are 4 swimming pools. There is the lap pool, there's a family pool, there's lap pool is number 1, number 2 is the children's pool, number 3 is the family pool, and then number 4 is the jacuzzi section, and then 5, 6, and 8 are the 5, 6, 8, and 7 are the entertainment and recreational areas. Now, then how do we handle this for the interior? For the interiors, we look into the emitters or pollutants, which are the volatile organic compounds. So you can see on the left-hand side, there are paints, formaldehyde, toluene and benzene, and people also use perfume and things like that. And the chairs have plastic, which are formaldehyde, which are contaminants. And so the research is on the plants on the right-hand side that absorb these pollutants. And so for this project, we use peace lily to absorb the pollutants from the interior. And also we created atriums. This is atrium, this project we designed in Korea, where we had atriums where we had vegetation along the edges of the atrium and at the bottom. And again, this is another scheme where we brought the vegetation from the ground, going all the way up to the top of the building. And you can see the vegetation climbing up and to the top. And that's the Maywa building. And so these are the patterns that we use for designing a building. But for a site which is extensive, what we do with this project is that we brought the vegetation, we collected all the species from the forest reserve on the right-hand side and brought it right across the site, so that by bringing it across the site, it enables connectivity of the species to other sites within the locality. And so this is the master plan. You can see the vegetation cutting across the site that has potential to join the adjoining sites. On the left-hand side is the forest reserve, and this is the vegetation pattern. And from there, it goes all the way across. Now, the trouble with master plan is that the roads cut our vegetation. And so you can see the white square shows where the crisscrossing of roads with the green infrastructure. And so to address this, we adopt what we call the eco bridge, where the vegetation can cross from one side to the other side, and the roads go underneath. So we call this the eco bridge, and this is what the eco bridge looks like. Now, how do we design for low energy? So we look into passive mode. So the approach is to increasingly reduce the energy level from the existing position, status, all the way by passive mode, mixed mode, full mode, and productive mode. Passive mode means it is, so now if you look into a country in a temperate climate, what you have is a cold winter and a hot summer. So, the blue line shows the temperature condition in a temperate climate. The red line shows what engineers want us to do. They want to have consistent temperature in the winter and in the summer. But that's a high energy solution. So the idea was that by using bioclimatic design, we can improve the comfort condition a little bit, bioclimatic design is not the answer to everything. So you can see the cold winter, by proper shaping and orientation of building, we can improve the comfort condition a little bit. And in the summer, we can improve a little bit. The mixed mode is where we use some mechanical electrical systems, and that from there, we can improve it further. But when we start using photovoltaics and low energy, then we can further increase it. But it is clear that it is very difficult to equal the red line. But of course, this is achievable. So we go beyond net zero energy, which is on the right-hand side down here. And so passive mode is where we use as a low energy bioclimate building without the use of any mechanical systems. And so for this project, what we did was that we shaped the course as we see earlier on, and of course on the east and west side. But one of the ideas we have is what we call an umbrella building, where the umbrella then becomes a shading device to the building below. And so on the right-hand side is a house that we did where the umbrella is actually a series of louvers over the roof of the building, and it's a double-story building. And so this is the building that we did. Oh, this is almost about 30 years ago. You can see the louvered roof on top, the secondary roof below, and then there is the first floor and the ground floor of the building, and this is the louvers on top. So this is what we call an experimental bioclimatic building, where it lowers the temperature without the use of any mechanical systems. And then for the water systems, we try and close the loop as much as we can within the building. But the water that is discharged from the building, we bring it back to the ground through constructed wetland and through bioswales back to recharge the groundwater. And so these are the bioswales, these are the eco bridge and the eco undercroft. So these are, if you like, a summary of the different devices we use in site planning. The bioswale then becomes a device that collects the rainwater and brings all the way down. But on top of the bioswale, we could have what you call a rain garden, where on a normal day it looks like a garden, but it floods during rainfall, so it brings the water, and then the water slowly filters going all the way down to the ground. But for the black water, we treat it as what we call a constructed wetland. It goes through a series of filtration ponds, and then by the time that it reaches the last pond, it is almost potable. And so for energy systems, as I mentioned, we need to respond to the climate. We look into different parts of the world. As you can see in Bogota, you are about pretty near the equator, and that these are the different systems we discussed earlier on. But what happens with the temperate climate is a temperate climate, you have a very cold winter and a hot summer, but we have the two mid-seasons, which is spring and autumn, which are nice time of the year. So what we try to do is to extend the mid-season into the winter, extend the mid-season in the summer. So in this way, we reduce the period in the winter for cooling, for heating, and the period in the summer for cooling. And so to do this, this is a project we did in London which is the Great Ormond Street Children's Hospital. We created a flue in the facade of the building that in the mid-season, it sucks the air up from the bottom going out to the roof. This is the valve at the bottom, and on the right-hand side is the valve at the top. And so in this way, we naturally ventilated the lower 3 floors without the use of heating and cooling, without use of heating winter and cooling in the summer. And you can see the glass flue going all the way top of the building. So this is, if you like, a summary of the different devices we use for lower the energy consumption. So the first one is passive mode. We use bioclimatic design to lower the energy consumption. Second is mixed mode, where we use turbines, some mechanical systems to cool the environment. What you see in the image is a retail center that we designed where the public areas, the public plaza areas inside the building are not air conditioned, but they're actually mechanically ventilated by turbines to suck the air up. And then for mixed mode, we use smart systems with low embodied energy to reduce energy consumption of the building. And then for productive mode, we try and use photovoltaics. Now, this is the image of a data center where we had a canopy over the building with photovoltaics to provide energy for the common areas. We cannot provide enough energy for the data center machines, but for the common areas, yes. And then the right-hand side is the where we have surplus energy that we collect by batteries that we can use for the rest of the building. So this is the roof that I mentioned earlier on. On the right-hand side is the roof seen from the air. Then the swimming pool then becomes an evaporative cooling device. On the bottom right, you can see how the pool is close to the living area. It collects the rain, and then now this is the measurement of the temperature. On the outside is 35 degrees. The pool area is 32.6. The first roof is 33.8. The first floor is 30.6. On the ground floor is 30.5 degrees centigrade. So this is how the umbrella concept in the bioclimatic design lowers the ambient temperature. You can see the louvers are shaped to let in the morning sun. And then on the left-hand side, on the west side, it is vertical and above to stop the midday and the western sun from heating up the building. So this is the pool which provides the evaporative cooling device. On the right-hand side is the living space. This is a scheme that we designed in China, in the Xiong'an area, where the whole roof becomes the canopy is a series of components which are fitted together. And this is the space inside the building, but it's not built. But the fitted glass that we used in the earlier building, we thought, what happens if we put it horizontally? So for this scheme, we used the fitted glass as a sunshade. Instead of the louver umbrella, we used the fitted glass as a sunshade over the university hub. And this is a scheme we're working on now, where we had a much more amorphous shape of the building as a series of vegetated roofs over the buildings below. And so back to this idea of designing for energy systems, and that for mixed mode we use ceiling fans, which are either down throw or the side throw, and that and then for this convention center we had an operable roof which opens out, if we wanted to. And so this lets in daylight and ventilation to inner spaces. And here you can see the operable roof open. Convention center sits about 5,000 people. That goes down to the performance of the presentation or the rostrum. That's a plaza outside in the middle of the building, and the client wanted to have a rainbow effect. So we had glass panels which are colored glass, and on the sun shines on the colored glass, it casts a rainbow pattern on the floor below. But to prevent this place from getting hot, you can see on the top right-hand corner this huge fans which blow cool air into the lower parts of the building. And this is the Great Ormond Street Children's Hospital. But for another building where this is a shopping mall, where existing is air conditioned, and the client wanted to have non-air conditioned areas, so you can see the yellow color, and the red circles are where the ceiling fans are located. And then we have glass louvers on the side so the air can go out, and you can see the ceiling fans in the top right-hand corner of the building. And so this is the data center with the canopy with photovoltaics. But to make it work, the photovoltaics has to be at least 50% to 60% of the area to be cooled. And so we don't have enough roof area, so we have to project it outside the building to collect the ventilation. And this is a building that is now currently working on in Bangladesh, where it consists of series of towers, five phases altogether of office buildings, residential, and retail. So this is what the building looks like. But out of interest, this was the original hand-drawn perspective. So we use AI to try and see whether we can generate perspectives. And this is a perspective generated by AI. So it's interesting because AI can help you actually produce solutions. AI produces 5 elevations for us in about 20 minutes, which would take us 2 weeks if we were to do it by hand. So in that sense, AI can contribute significantly to enhancing an architect's work, but it doesn't work automatically just like that. You have to feed in the right input into the computer. You have to then when it comes out, it's not exactly 100% perfect. You still have to edit it, but it's a good way of generating the aesthetics for a building. So this is that Bangladesh project. And then now next thing is that the most important aspect of architecture is to make people happy. So how do we make people happy? So one of the thoughts we had is that the brain produces certain hormones called oxytocin, endorphin, dopamine, and serotonin, and that different activities encourage the brain to produce these hormones. So we thought if this is the case, then this is what happiness is. So we need to design spaces, activities that enable people to produce these hormones. And we started looking into spaces that will then engender the activities, the spaces, both internal, semi-internal, and open areas, to encourage people to emit these hormones in the brain. So this is what I meant by so architecture then is not just about doing green design, it's about designing to make people happy. And this is a scheme where we had a rooftop jogging track. And so now I'm going to end. These are the key takeaways from my lecture today. Nature consists, ecological design consists of nature, and we need to emulate ecosystem attributes. We need to create habitats within the built environment. We need to imitate the provision of ecosystem services to create what we call a constructed ecosystem. And this in a single sheet, we summarize the key factors that we need to consider. What are design objectives? On the right-hand side is we have to integrate all this by design. Now, this is, if you like, an ideal situation. I haven't been able to achieve this 100%, that everything you do is essentially experimental, try and push the field as much as possible. But, that's what makes what we do very lonely, because I can't find anybody else to work with us. People are not that interested. In fact, some architects look down on the ecological approach. And so that is the biggest problem I encounter in what we do. But I believe that if we focus on this, we can progressively make our cities into constructed ecosystems through from present day to intermediate to traditional to transformation and the eventual solution on the top right-hand corner. This is my aspiration for the planet, for the cities, and for the urban areas in the world, that progressively convert them into constructed ecosystems. This is a drawing that we did of the key factors in designing eco-city. You can see that, green areas on top. We're going to have a constructed wetland. We have green, we have vegetated bridges and so forth. And so it is clear, and this is my single message to all of you, that we just cannot continue to design and build in the same way. We have to change. We have to design to consider nature, consider our human society, consider hydrology, consider our built environment, and consider energy systems, and to integrate all this by design. Now, I gave this lecture recently in the American Institute of Architects. The Americans have what we call the framework for design excellence. And so that there are 10 factors: design for integration, equitable communities, ecosystems, water, design for economy, design for energy, and so forth. The Americans actually call this the 10 key factors. They call them the 10 commandments, 10 commandments. And these are the nature, human society, built system, nature. These are my set of factors. And this is how, for instance, what my design for ecosystem is what we try to do. And this is how what we do correlate with what the Americans are doing in their code Committee of the Environment in the Framework for Design Excellence. I'm going to end with this because, in those of you who have watched Sesame Street, there's the frog, and he sings the song, "It's not easy being green." And that's, if you like, is the story of my life. I've been working on this for nearly 20, 30, maybe 40 years. It hasn't been easy, but it is a mission that we try to do in our work. Thank you.
Thank you so much, Dr. Yeang, for this lecture, for this masterclass. I think it's pretty much been an hour for lots of learnings for all the attendees. I'm going to open a space for questions if anyone wants to ask something. Otherwise, I have a couple questions to ask you.
Yes, ma'am.
Well, that's what you were saying right now. It's not easy to be green. I agree with you. I have been in this field not for that many years as you have been. Well, I want to ask you, what events or what influence did you have in your life for being interested in sustainable architecture?
Oh, when I first started, I was appointed as a research worker at Cambridge University to work on a project called the Autonomous House. The Autonomous House is a project that was mooted by Buckminster Fuller for a house which can exist without connection to the city grid, without connection to the city grid, without connection to the city's energy, city's water supply, sewage system, the food systems. So it itself is autonomous. When I work on that project, after 3 months, I realized that it is mostly engineering. But the theory, the ecological aspects of it has not been worked out. So I said, look, I told my boss I couldn't work on the house, but I want to work on the theory. And so he let me leave the group leave the group and started on my research. And so this led to my doctorate at Cambridge University on ecological design and planning. It took me 3 years to work on it, and that became my life agenda. So that's how it all started about 30, 40 years ago.
Thank you for your answer. I think it's a great vision. I think that we see green architecture right now probably as a trend, as something that it's more modern. But as you're saying, this has been here for a while, and that's why I think your work is so recognizable. You have so many years of experience. I think you have been, as I said earlier, a pioneer on this. So that's, again, one of the reasons why this masterclass has been so representative for a lot of us. I have a question for one of the people in our audience. Could you please share your vision on the future of architecture and how bioclimatic design principles will contribute to creating more sustainable and resilient urban environments?
Well, as I mentioned, bioclimatic design is a subset of ecological design. Okay, bioclimatic design enables you to lower the ambient the temperature consumption by a certain percentage, but not a lot. It's only part of ecological design. So we should move from bioclimatic design to ecological design, which is what I explained in my presentation.
Thank you again for your answer. Can you please tell us how you address the challenges of complying with local and international regulations in your sustainable projects?
Well, that's what I showed. One of the examples of international requirements is the AIA 10 principles, and that matrix shows how what I do integrate, addresses some of the principles that the American Institute Architects, recommend that their architects to comply with. And so that we are not working in isolation, but we see what we do in the context, the greater context of what the world is doing. I have a table which I didn't show, how I had all the different rating systems in the world, the LEED, the CASB, BREEAM in UK, and that how our approach interacts with all these different rating systems in the world. But I didn't show it today. I have it, somewhere in my office.
I'll try to look for that table probably in your website. Thanks again for your answer. We have some students here today as attendees. So my next question will be, what do you think the role of education plays in promoting ecological architecture? And as well, what advice would you give to your architects to pursue a career in sustainable architecture?
Well, that's an interesting question because I get asked that quite often. You have to change your curriculum. You cannot teach architecture the same way as you're doing now. You have to start with ecology. And when you start with ecology, then everything that you teach changes. When you teach materials, it's not about weathering, about how to join material, but where does material come from? How you extract it from the ground, how you manufacture it, how you treat it, how you transport it, and what happens at the end of its useful life, how you reuse it and recycle it. And so that changes the way you think about architecture. So when you look into the internal systems for a building, it is not just air conditioning or ventilation. You have to, as I said, you have to start with teaching bioclimatic approach, the proper shaping of the building, the facade, the use of the ambient temperature and the wind direction, and then mixed mode where you can improve the comfort condition a little bit with some mechanical systems. Then you have the full mode, which is smart systems to make it low energy through automated systems and through smart systems. Then you have the productive mode where you generate your own energy on site through like photovoltaics or wind energy. Then suddenly you realize that teaching architecture is very different. To make a building using photovoltaics, you have to use photovoltaics on the roof. You have to use glass, which has embodied energy photovoltaics in it. And there are many companies now in the US that produces glass, and then you can use wind energy. Wind energy means that if you have to assess the wind for that locality. If the wind in that locality, if you don't get a consistent 5 meters per second consistently over the whole day or most parts of the day, you cannot use wind energy. So it's not as easy as it seems. You have to look at the local climatic conditions in that locality to use energy. Then you have to look at water. Water, you have to close the loop, close the cycle. Water is a resource, and you have to harvest the rainwater for that locality. Then you have to treat your black water, the sewerage, in a natural way, not just through putting into a septic tank or into a treatment tank, but you can have constructed wetland to treat it. And so, these 5 factors, that's nature, the ecology, the ecosystem, biochemical cycles, the built environment, and how we can reduce waste and emissions. And third is through energy systems, water systems. And at the same time, you have to design for people. You know, the other day I was in New York and somebody showed me a building which says, oh, this is the LEED certified platinum building. And it's by a very famous architect. But I said it's goddamn ugly, you know. So you can have a truly green building, but you have to make it beautiful as well, you know. So for me, architecture, you have to address these following components. First of all, it has to make people happy. If it doesn't make me happy, then what's the point? It looks like a prison. It looks like a dreadful, tenement flat. So it must make people happy. Second, it must be green. So all these factors that I spoke about today. Third, that it must meet criteria. You have to design within cost, on time, meet authorities' requirements. And the fourth one is that it must be beautiful. So if you achieve these four objectives, it is make people happy, make it green, meet criteria, make it beautiful, then you have the beginning of what I consider, architecture.
Thank you so much for your answer. I agree with everything that you just said. We have one more question. Thank you, Carla Alvarado, for the question. What is the artificial intelligence technology that you usually use in your office that is recommended for your architecture teams? And how have those technologies contributed, especially in your designs?
Well, as soon as you use an intelligent software, things have moved. Other people have developed new software. So, for instance, the one that you saw, I used a software called LookGBT. But now there are better ones called Midjourney. There are a few others, So, you have what you want to do. That is that artificial intelligence can help us develop the planning, develop aesthetics, but we're still not able to use artificial intelligence to produce contract documents and specifications. So there's still a lot more to be done for architecture using artificial intelligence. But I don't have the time to do this. Just doing what I'm doing now is taking so much effort already. So, but we try and use artificial intelligence to help us a little bit to work on aesthetics. But there's so much to be done in this field that we're just scraping the top of the iceberg. There's a lot more at the bottom that we should work on. And now, this is, if you like, my mission in life, and I've been working on this for several decades. But what is clear is that it's very difficult to be an architect. It's very stressful. And that when I talk to students, like what I'm talking now, and from my experience, being an architect is very stressful for a number of reasons. First of all, it is a cash-driven business. That means a client appoints you, but you have to do the work first before you get paid, right? Sometimes you don't even get paid. Some people owe you money and they'll never pay you. Okay, so if you have a restaurant, people finish eating, they pay before you leave the restaurant. So that's what makes it very stressful. It's a cash flow driven business. Second, if you have a company or if you have a practice, it is delivery intensive. Delivery intensive in the sense that every day there are 3 or 4 things you have to do on that day. If you don't do that day, someone's going to get annoyed with you. You have to deliver a set of drawings. You have to do a letter of award. You have to get approvals. You have to get it done at the same time, So that's the second factor, is delivery intensive. The third one is that you do multiple business functions. Now, if you're in the car business, the person who manages the car company does not make the car, does not sell the car. does not service the car. But as an architect, you have to do everything. You have to get the business, you have to do business, you run the business, you have to fund the business. And so you have to do multiple business functions. These are some of the reasons why it is very stressful being an architect. So I tell students, if you don't have the real passion to do architecture, please do something else. You have a much easier life, right? But if you have a passion for architecture and you love making things, you love designing things, then be an architect. But you don't have this passion, it's much easier to do something else, have a much easier life, be kinder to yourself, So unless you want to do something else, unless as an architect you do IT systems or you don't practice an architect, or you practice as a hobby. So once in a while you do a competition, once in a while you do a project for your friends. But if you have a practice, it is very, very stressful, and that's what has been being very difficult for me. So now, one advice to your students is this, okay? I started business several years back, and there were 4 major practices in town who have 80% of market share. So how do you compete? How do you compete with the big firms or the major practices? So one of the things I decided is that I learned how to compete by learning business. See, all these big firms, all the principals, they do business through trial and error, through a period of time to learn how to do it, through experience, through trial and error. What happens if you attend a course on doing business? Then all of a sudden you compete with them, you're there with them, because while they're trying to do business in an intuitive and through the clubs, through the network, we suddenly learn architecture intuitively, systematically. So I would advise all your students, if you want to be an architect and you want to practice an architect, when you leave architecture school, attend a course on business. Then you start to realize that doing architecture can be a very systematic way of doing it. It's still not easy, but at least you have a method for doing business. Okay. Let me just show you something. Can you wait a few minutes before we end the discussion?
Yep, thank you again so much for your time. We know it's past midnight where you are, so we're again really honored that you're spending this time with us.
Okay. Now I started to work on the theory of doing architecture. Okay, so this is my diagram. An architect has to do 4 things well. He has to get the business. That's number 1. He has to do the business. Is this upside down? Yeah, no, number 2 is the do the business. He has to run the business, and that's the finance the business. And you're here, you're right in the middle. So photograph this, give it to all your students, and tell them these are the 4 things you have to do well every day. Any of these you don't do well, your company's in trouble. So these are the 4 things you have to do. I've actually, started working on this about a few years back. I've started to list down what exactly it means. So here's a sheet of paper which has all the things that you have to do in these 4 things. So if you write to me, I can give you a copy of this. Okay, nothing I do is copyright. Everything is free. You all get it from me, and I hope it will benefit you. But I learned this from attending business courses. And in 2002, I attended a 1-week course at Harvard Business School. And so when I attended the course in 2002, I said to myself, I should have done this 20 years earlier. So, okay, I've enjoyed talking to all of you. I wish you a good life and a happy life as an architect.
Thank you
Oh.
so much again.
Yeah. Okay, so
Well, I don't know if Marisa is good with good connection. Dr. Kenyang, I am pleasure with your conference. Thank you very much. Thank you very much for your advice, especially for the last advice of making architecture as a company, as a business, as a process of marketing, administration, and so on. Is super important for our business and for all the advices that you put in this session. And for my part, it's an honor to have you with this time due today in this space. I am pleasure that you give us a lot of minutes for us with your knowledge. Thank you very much for my part. I don't know if Felix have some words.
okay, all right,
Professor
thank
Yeang,
you.
we appreciate your knowledge, you sharing your knowledge with us, and we also welcome you every time you want to share. Every time I attend your conferences, you open a whole world of topics, and it's very important and very interesting to hear you again. So
Okay.
we appreciate that. We thank you for that, and
Okay.
thank you for your time.
Check out my latest books in Amazon.com. I've
Will do.
written about 14 books. The last 3 books are I think the better ones. I'm still working on a new book, which is even better, but check out my books at Amazon.com. It summarizes a lot of things that I mentioned today in these books. Okay.
Yeah, we
Thank
will.
you.
Thank you. Thank you.
All right. Okay, right. Thanks. All right. Bye.
Okay, thank you very much. See you.
Thank you so
Thank
much.
you. Thank you so
Yeah.
much. See you. Bye bye.